Okay. Lovely. Okay. Right. So, test-driven development. Who's been here from at least one of the previous sessions? Okay. Good, good, good. That's great. The obligatory slide. Feedback. Who is not on the Slack yet? Who is on the Slack? Okay, well, go to that address, slack.cpp.al, Alpha Lima at the end. It's free. Who doesn't know what Slack is? Everyone knows what Slack. You don't know what Slack is. Slack is just a chat application. So if you Google for Slack, you can download their desktop application, or if you don't want to, you can just use it in your web browser. It's up to you. But we have a channel there, and you can talk to us during the week directly, ask about problems, whatever. So if you're not on there, get on there. It costs you absolutely nothing. Life advice. Well, I'm not sure about life advice, but maybe. Who knows? So we'll have a recap of the previous lesson, which happened a few weeks ago. We had a reasonably intense session of coding this little bowling application that we're still working on. And we focused primarily on a sort of very interesting and somewhat contrived problem of a monetary class dealing with currency for our bowling thing, to charge people for not bowling. So what am I saying? Blockbuster rental. Ignore bowling. It was rentals. It was rentals of videos. That's completely. And nobody said anything. I was just trying to work it out. Oh, I just quietly said it. Yes, sorry. That should be a rental app. Sorry, a generic rental application, but focusing on video initially. And it was not bowling. It was video rental. It was obviously, while I was doing this, I had a Freudian slip and was immediately thinking of the bowling TDD thing I did ages ago, and in fact not what we actually did. There were lots of interesting thoughts and approaches. It was very interactive, actually. For those of you who missed it, we will get back into it hopefully today as well, and crack on from where we were. And if you did miss any, don't worry. There'll be the code's already been pushed to the internet, so you can just grab the code and do it with us from where we left off. And as I was saying, we had some very amusing mathematical challenges since we had a sort of contrived problem where we'd split the pennies from the pounds. And it did actually make it a bit more complex, but it was arguably sort of part of the fun of this. And obviously, it's to learn, right? Things you wouldn't necessarily implement in real life can still be used as an interesting challenge when you're practicing. So, don't freeze on me now. Okay. So we're going to talk about behavior-driven development. And as always, I add a quote, except this time I just made it up myself. Given a section slide, when I create it, then I must add a quote, which in this case I have, even if it's somewhat meta. So who knows what BDD is already? Who's familiar with BDD? One? Wow, okay, excellent. It's going to be a learning experience then. So I'm going to talk about the core pieces of BDD right now. It's slightly broader than this, but these are the bits you'll really care about. So first of all, in comparison to TDD, it's really just a way of thinking about a problem, something you need to do, and addressing it. Right? It's a style. It's not something that's orthogonal to TDD. It's very much sort of a part of the family of taking this approach of writing tests first. You could technically write your behavioral specification first. After you've written your code. But then that wouldn't be the red, green, refactor style. You could do it. You could write tests after you've written code as well. That's not TDD. Technically speaking, it could be BDD, but it's not the best way to do it. So, in summation, it follows a very common pattern, right? And there's a little bit more to it, but these are the core bits you as a programmer are generally going to care about. We have a given. So, given something or some things in a particular initial state, right? So, I'll give you an example in a sec, but initially you have the given state, right? Given something, given that something is like this, right? Then, when we then do something with that state, we call a function, right? We do something, when we do something to it, when we cause a change, ask for a result, whatever, then that result should be whatever we expect. Given when then? Given initial state, when we do something to it, then it should be like this afterwards. So, for example, very simple example, given the numbers 4 and 6, yeah, when I pass 4 and 6 to the add function, well then that function should return 10. Very simple statement, right? Very simple way of representing the problem. Initial state, I cause a transformation by using those values, and then that should give me back 10 as I expect. Now, before I continue with these slides, there is a slight expansion. Right? Usually you have what's called a scenario. So in BDD, you generally say, as a developer, I want a function that can add numbers together. So given that I have 4 and 6, when I pass them to my add function, then it should return 10. That's an entire scenario. But you can obviously have multiple. You can say within a set of scenarios, I have, as this user, I want it to do this. Given I give it 10 and 7, when I pass those to the add function, then it should return 17, and so on and so forth. But there's an evolution to BDD. BDD in its simplest case was just using essentially human readable language to express what a test is doing, which obviously makes it much friendlier. If you just do pure TDD, sure, you're writing code, and that code will call the function, it will pass it 4 and 6, and it'll expect that it's got 10 back. That's fine. But when you do BDD, you are embedding in your tests, in human readable language, what it's doing, which makes it much easier to understand. Sure, it could just be pure code, it could just be pure TDD. Someone can come along, they can probably read it and understand it anyway, but it's a little bit faster when you've got those nice sets of sentences, right? Those 3 separate states where you've divided up the operations. You have the part for the initial state, the given. You have the part for making the function call, doing the transformation. And then you have the final part for verifying that everything is as expected. It's very readable. But an enhancement to this, and a very common use case that's BDD driven, or BDD based, is regex extraction of the terms inside the given, when, and then. Regex is regular expressions. So who doesn't know what regular expressions are? Everyone? Oh, okay. So regular expressions are a sort of, not really a programming language. They approach one, but it's simply a way of having some string. You can extract bits of that string that you're interested in, parts that you're interested in. So, if we can do that, it will then allow non-programmers to write the given, when, then cases for us, right? Someone who doesn't know any C++, they're not a coder, right? But they do have ideas on what stuff should do. They can say, given I have this number and this number, when that's called, when the function is called with that number, then it should be whatever value I'm expecting. And they don't need to write the code to do it. They just need to write some English that says what they expect. But obviously our code needs to be able to extract the numbers. In the case of the previous example, we need to be able to extract those numbers out of the human readable English. So they need to still write it in a consistent format. But presuming they do, it then now enables someone who doesn't know C++ or whatever language it is to write more and more cases and see if they pass. So I, as a programmer, write the test once, and someone else can think up ways to try and break it. So, obviously, you want a framework to do this extraction for you. Yes, okay, you can build anything you like from the ground up, but realistically, you want something off the shelf, right? And there happens to be one. It's called Cucumber. It's not C++ based. It's written in Ruby, but it's designed to support a wide variety of languages. I'm not going to go into Cucumber in this particular lesson. We're going to use the BDD style, but we'll use it within Catch. This regex extraction is generally something you'll encounter with QA teams. It's a QA tool. You as a developer may end up using it, but your QA team's going to wrap Cucumber around your tests, and you'll get the parameters pre-extracted usually.
Do you have to consider that when you're designing your code?
Consider what? Sorry.
Whether they use this cucumber side doesn't affect your actual.
It doesn't affect. No, absolutely not. It does not affect the code. It is purely tied to your tests. Cucumber does not, or it certainly should not, have anything to do with production code. It should be purely tied to the test code, the code executing the test, the code that is the tests. Oh, sorry, was there a question?
No,
oh, okay. So, for example, right, you know, the previous, I've repeated example there, we can use a regex to do the extraction. So here's an example of a regex. So we have given the numbers, as in the previous slide, and then this is the special regex syntax, right? This is, again, regex is a standard thing. If you've ever used grep on the command line, grep is a sort of it's not true regex, but it uses some of the functionality. So in this particular case, we have the parentheses, right? Again, this is regex, not C++, which tells the regex engine that we're interested in whatever is inside these parentheses, the round crescent brackets. We then have the square braces to represent a range. So we want anything in the range 0 to 9. And then the plus symbol means that we want one or more numeric digits, right? One or more of this range. So if I write 3, then it will capture, the regex engine will capture the number 3 for me. If I write 333, it will equally create a variable that is set to 333. Then we have obviously the word and, you know, just the word. And then again, we want to capture the second number that they want to add. We don't care about the when, the when clause. We don't care about the when clause because it has no data to extract. When I pass the arguments to add, there is nothing to extract there. Okay? C++ doesn't have runtime reflection. It may be in, say, Java, because you have the ability to do reflection, you could extract the function being called if you're being really clever. But we can't do that in C++, so we wouldn't care. We have nothing to do with it. We don't care about the when clause. We do care about the then clause, though. Because, of course, as part of making this test generic, we need to capture what they think it should return. So now somebody can just write, given the numbers 5 and 5, then the function should return 10. Someone can just write that, and our test will take care of it. It will receive those parameters through Cucumber. And, yes, sorry, question?
What if you're updating, say, a reference of arrays, as in one of your arguments? You're just you've got a void. You're sending a vector, an argument in, and you're updating a reference.
So,
inside it.
Also in this.
The function won't return anything as such, but it will update.
Well, so if this was C++, our add function is going to take 2 integers, right? If the person writing the English bit, this, a given when then, if they mess up the test and they fail to correctly format it like we expect, then their case is invalid and it won't run. And they'll just get an error from Cucumber because it's not actually matching what's expected. They've written a bad test and it will tell them they need to fix their test or their case.
You can still write a void function then with 3 arguments and return the third as a reference of the
A function returning void can't return anything, right?
It can update the third argument as a reference.
I see what you're saying. So you would have a function that takes 3 arguments, and then it just updates the third argument. That's internal to your code. That again has no relevance to the person who's writing the given when then part. They're not the programmer, right? Okay, if it's you initially doing it, which it probably is, you're going to write some case. But you define your API. It doesn't matter. However you choose to use parameter 1, parameter 2, and parameter 3 is up to you, right? Whether it's the return value of a function or whether you end up having a reference and getting it out that way, that's internal to you, right? If you decided later to refactor it so that it was a return value and not a reference, it shouldn't break any of these tests. Those tests shouldn't. This syntax, this format shouldn't care about the internal implementation of how you get the job done. So, let's talk about catch and BDD. The most important thing is that it's supporting BDD style tests, right? It's not this sort of modern evolution, unfortunately, where we can actually extract data. But it still has arguably some value, even though it's not offering this regex functionality, right? It gives you a nice way to structure your tests, and it's also a way of thinking, essentially, right? It enables you to come up with a structured scenario for what you want to make sure your code does. And then once you've satisfied that, you can move on to thinking about the next thing you need your code to do. When it's in, given that it's in some state, when you do this other thing, it should then be returning or in this new state, right? Sorry? Oh, okay. So yeah, we covered catch in our previous lessons. Basically, catch is a test-driven development framework for C++. So no, it's not. So it's sort of in the family of the general purpose of testing, right? Cucumber is oriented around this concept of testing code. Catch is in the same family as that concept, but catch is specifically for C++. It gives you a way of writing unit tests very conveniently, very quickly in C++, and then it also has a lot of reporting around those tests that's just baked in for you. So it will take care of generating machine processable XML reports, right? If you have a continuous integration environment such as Jenkins, Travis, what's the one, Team City, right? There's all the, there's commercial products, there's open source products that will be able to build and test your code. Those products generally can then execute your tests, and they expect some machine readable format that they can then analyze to see, did any tests fail, what should we do? Catch will take care of generating an XML report that the vast majority of commercial and open source continuous integration systems can process and then act on depending on what you want them to do. So catch is just an extremely convenient framework for unit testing. Additionally, if a test...
If you go to our YouTube channel, we have Phil Nash showing catch
Yes.
in action.
We have Phil Nash showing catch in action. We also have this module as well, obviously, using catch in action. We will use it later as well. Yeah, and as I was saying, even though it's not got this regex functionality, it does let you still present them in this nice BDD style of given when then, and that has value, I believe. Structuring your tests in this way usually will make them more readable, right? You go off for months, come back to something. What is it doing? You've got that human readable bit to help you, or somebody else if you've got a teammate, right, or teammates. Basically, give it a try, and see if you find it helpful. See if it helps you out. If it enables you to think about tests maybe more easily. So,
It's a header file.
About catch, sorry. Yes, the nice thing about catch, as was said, is that it's header only. Actually, well, now that's optional, technically, these days. You don't have to take the header-only version. So I would recommend everybody in this room, anyone who's a beginner, just get the single header version. It's much easier. It's now offered also as something that's not a single header and actually split up. It's really just for people who've got big projects and they're worried about compilation times. So for performance, there is now a split up version. As a beginner, don't worry about it. Just get the single header version. It's super simple. You just include it, off you go. So we're going to get into a bit more of mocking and an actual quote this time. A programmer's wife tells him, go to the store, pick up a loaf of bread. If they have eggs, get a dozen. And the programmer returns with 12 loaves. Hope you'll get that joke. So first of all, a brief, recap of mocking, of course. Oh, is it failing? Don't fail me now. Right. So the core purpose, obviously, of mocking is so that, one, we can keep classes separated. That's probably a controversial statement, actually. You could argue it's also, maybe the core purpose for many people is that they just don't have an implementation for something yet, and so they need a mock because they're going to plug it into someone else's code, and that person's still busy writing it. But they can still have a fake, a mocked-up version that will attempt to simulate in their tests what they expect to be written by the other guy, the other programmer. So, you know, we generally in C++ will need to create an interface, a base class with pure virtual member functions, which I'll bring the code up in a minute to remind you if you've forgotten. And obviously the class that we're working on, the one the real production class that we're going to use in our real code, will obviously take a reference or a pointer to that interface. And then the tests will give it a mock implementation that satisfies the interface. And obviously that mock implementation should have the ability to verify that our real production code that we're testing is calling the correct functions that are part of the interface, the functions on that mock, with potentially the correct argument values. You know, if I have a mock for a class that adds numbers together, then maybe I have a particular class that I'm writing that I'm going to test. If I give it the numbers 2 and 2, I expect it to call the mock and also give the mock 2 and 2. And so my mock class can do that. And of course, then the mock class should probably return 4. So I can make my mock return 4. Although maybe I want to actually test how my class copes with wrong values. I can make my mock actually take in 2 and 2, but give back a bad value, give it back 5 instead, and see how it copes with that. So let's just focus on how you would implement a mock, right? So you have, as usual, your interface. So this part is your production code, right? The interface class, which is in this particular case literally called interface, as it happens. This is the common part that's describing what functionality is going to be offered by implementations of this thing, right? So obviously all its functions are public. We have this virtual keyword with the equals 0. Who would like to detail what that does? So we have, for example, virtual bool. I know you know. Virtual bool do stuff equals 0. Who would like to describe exactly what that line is describing, defining, declaring? So it's pure, but what does it really mean? What does it really mean? So we can't instantiate. So we can't instantiate the interface class. We can't have an instance of this because it's got at least, obviously, these two are both pure virtual, right? But if as long as there's at least one, you can't create an instance of this thing. The equivalent keyword in Java. No. If the question was what is the equivalent in Java, for example, you would just use the word interface instead of class. Java has this concept literally baked into the language. You either have classes. Java has abstract classes as well, but this isn't about Java, so we'll skip over that.
Was that the equal 0 is equivalent to declaring that as an abstract function?
It's saying that.
Must override.
Yes, precisely. It's saying that this function is not a thing inside interface, but somebody is going to inherit from this, and when they inherit from it, they will more than likely create a real concrete implementation of this. So that's the equals 0 part. What would happen if we didn't have equals 0? What would we need to do if equals 0 was missing? I know it's been a few weeks, but I'm trying to see who's... That's true. If we don't have the equals 0, a derived class wouldn't have to override it. But why not though? Why wouldn't the other class? What would we have? What do we also have to do then in interface? What do we have to do in this class if we don't use equals 0? Precisely. If we don't use equals 0, it needs to have some curly braces, and it needs to actually have some code that returns a Boolean, right? But this is just an interface, so there's no actual code for this. And obviously then we have another member function on the class called do other stuff. It takes an integer, and it returns a string. And again, it's pure virtual, meaning it has no implementation. Somebody else is going to implement that. And finally, we have our destructor, which we've declared as virtual, and it is explicitly defaulted. Who remembers why that matters? This one's a little bit nuanced.
Destroy the whole tree.
Sorry?
Destroy the whole tree. So you inherit further down and destroy there. It doesn't destroy this.
Almost. Yeah, Michael, go on.
If you call a function that takes actually the interface and not the derived class as an argument, then if you call if it calls the destructor on that element, it may happen that it actually calls the destructor of the interface and not of the derived class.
99% there. 99% there. 99%. So the 1% is, so as Michael said, basically, we need it to be a virtual destructor, because if someone takes a pointer, say a unique pointer, or whatever, to interface, i.e. they take ownership of some implementation, they don't know what it is, but they're taking ownership of it, and they need to obviously release the memory, destroy it, they obviously are going to, the compiler is going to generate code to call the destructor. When the compiler does that, if it's not marked as virtual, it will simply say, well, okay, interface has a regular destructor. As far as I know, this is just interface. Interface doesn't have any data. There is nothing to do. Except in reality, whilst it thinks it's an instance of interface, it's not really. It's some implementation which probably does have data. And now it's going to leak the memory because we're not going to call the destructor of the implementation. So by using virtual, the compiler now ensures that it always generates code that will dispatch upwards through the class hierarchy to the implementation. So when it's declared virtual, when we destroy it, not only will it still call the destructor of interface, it will also look and see if there's any implementation higher up that also has a destructor that needs calling, and it will make sure that that is called, and that will guarantee that all the memory is correctly released. Any behavior in the destructors of the implementations is called. They will do what they need to do. It prevents memory leaks, it prevents bugs. That's why we have it. And if it never gets used, if you're using a modern compiler, it will cost you nothing. With LTO. Yes. So, no. The question was what? The question really is why have we got it virtual? So the reason it's equals default is because we don't need to give it a code body, right? I could have used empty curly braces, but that's actually suboptimal because then it's not considered a default destructor, and potentially you would get less performant code. Using equals default is the C++ idiom, right? The destructor in this class needs to be virtual, so I have to declare a destructor with virtual, but I don't need to override or give it any special behavior. So I just use equals default, tell the compiler that this destructor, whilst it is virtual, has no special behavior, generate any, the code you need to, or in this particular case, none really. But it will ensure at least that any implementations will have their destructors called. Question?
Whenever you make this structure pure virtual, it will cause some problem when it's moved up from the derived.
You could make the destructor pure virtual. That is not a pure virtual destructor. There's really only one reason to bother making your destructor pure virtual, which is that you don't want anyone to be able to instantiate the class. However, all of the other functions that you provide are not pure virtual. So imagine that do stuff actually had a default, had some real implementation there, right? So it wasn't pure virtual. It was virtual, but it actually had some code. And do other stuff also, whilst it was still virtual, had some code. But I still don't want to let people instantiate this thing. Then a way out is to make the destructor pure virtual. But then that's a bit of it. Go ahead.
Couldn't you just delete the constructor?
Delete the constructor? No, because then derived classes won't be you won't be able to instantiate derived classes because when I instantiate a derived class, the constructor of the base must still be called. And if you've deleted it, you've now got a class that's impossible to construct.
And set the constructor to
Pure virtual does not apply to constructors. You cannot make constructors virtual at all. So if I make the destructor pure virtual, that's one way of preventing instantiation if there's nothing else that's pure virtual. Try and avoid it, to be perfectly honest, because the next complication is that if you do make the destructor pure virtual, you then have to give it a definition anyway outside of the class body, because it has to be something to call. Using pure virtual is just a way of saying that you're not allowed to instantiate this. You could still go ahead, and this is really, don't worry about this, but now that you've gone down the alley, I've got to tell you anyway. You can go outside of the class and then create a definition of do stuff for interface. You interface, bool interface, : do stuff, and make it do something. It's a really niche corner case. It means that derived classes are able to call do stuff on the base and make it execute that functionality. It's a very, very niche case. Avoid it. Avoid making the destructor pure virtual. Stick to this simple one, right? Just interfaces have pure virtual member functions, and you just default the destructor. It's super simple. Don't try and be too clever. So we're now going to have our mock class, right? And of course, the syntax in the case, or is it going to be catch that I'm using? Yeah, it is. So if we use the if we use the trompe-l'oeil framework, which is a very convenient C++ piece of code that gives you a framework for doing mocking, then it enables me to, first of all, declare a class called mock. And of course, it's inheriting publicly from this interface class. So now we have this is the derived class. And we just use some macros that are in the trompe-l'oeil framework. So we have make mock 0. Who remembers what the 0 means? The 0 represents the number of arguments, which in this case is none because it doesn't take any arguments. So obviously we then say we want to make a mock for the function called doStuff. We then have to provide its signature, the signature of the function. So in this particular case, it's a bool because it returns a bool, right? You see that there's the bool there. So it returns a bool, and of course then we have empty parentheses because it doesn't take any arguments. And we then use this override keyword is just to ensure that the compiler's happy and to show anyone that we expect this mock function to be an override of what is in the interface. Because you can make a mock member function that is not overriding anything in the interface. You can not include this, and you can just define a brand new function. Technically speaking, we could leave it out here as well, but the compiler will give us a warning because this nonetheless is overriding. It's got the same name. So the compiler will then complain at us and say, well, you didn't use override. You probably should think about using that. So we use it because it's best practice. It makes sense. And then, of course, we've got do other stuff. So, of course, now you see make mock 1, right? Does this make sense to everyone? Why we've got 0 there and 1 there? Anyone not clear on why there's a 0 for the first one and a 1 for the second one? Yeah.
Why couldn't they just put everything in the right order?
What do you mean?
Why can't they have standard string, do other stuff, int, override, and mock?
Oh, well, that is a...
It's just too much when you look at it
That's basically because this is really a macro generating this wrapper function, right, to support all of the pieces of trompe-l'oeil. So consequently, they do need to have the name separate from the signature. It is how they build it, right? Because this stuff gets reused when you're writing your macros that expect calls and return whatever. So obviously in this case you have make mock 1 because this function takes 1 argument. So again, it's called do other stuff. It returns a std string, the function, as you can see here, this is what the function returns, and then it takes an int. So it does look a bit weird, this syntax, obviously. Again, it is a macro for a framework, so try not to be too confused by it. And we're done. That's it. We've made a mock class with trompe-l'oeil, right? You include the header for the trompe-l'oeil framework, and boom, you've defined a mock for your interface, which you can then use. right? We want to use the mock. So everything on the previous slide I have now just chucked together in this box. We've got the interface as it was on the previous slide. We've now got the mock directly below it as it was on the previous slide. And obviously now we want to actually use the thing, right? So we have a function that we're going to test, right? This is the real piece of implementation code that I'm going to write a test for. No. So if you want to take notes or anything, feel free, but I'm just describing it. So this is everything in the previous slide, and this is a function that we're going to test. So as you can notice, it takes a reference to the interface type. It knows nothing about this mock. It doesn't know it exists. It only knows interface. And does anyone know what would happen if I deleted the ampersand and tried to compile it?
Tells you that you cannot instantiate the interface.
It will fail to compile, and it will tell me I cannot instantiate the interface because it has at least one pure virtual member function, precisely. So we can either take a reference or a pointer, precisely, right? Why do those work? Why does it work if I take a reference or a pointer? Yeah, go on.
Well, I would assume the interface itself just describes the size of the memory that needs to be allocated for the object. So, as I'm expecting only to call the functions which are defined, or the methods which are defined for the interface, all I need to know is the memory layout of the object.
Yes. So basically, if you take a reference or a pointer, you're saying, I want to use something that already exists, right? I don't need to create an instance of the thing because I just want one that already exists. And obviously, this has got pure virtual functions. If it was just by value, I can't create one of these. I'm not allowed to. But when I say I want a reference or a pointer, I'm not creating a new one. Someone's going to give me something that already exists. And then, obviously, in the case of this code that you'll see, what they're really going to give me will be this, the mock. So we're going to call do stuff. This is our implementation code. This is the code we're going to be testing with a unit test. So it's going to just see if everything's okay by calling do stuff on the reference to whatever it's given. It's then going to call do other stuff, and it's going to pass 1, 2, 3, and store that in a variable we're going to return. And then if OK is true, we will append the word OK to the string that do other stuff returns. Otherwise, we won't put OK on the end. We'll just return it as is. Make sense? Simple enough, right? Somebody will give us some implementation of this thing. We will call do stuff, which will be true or false. This will be true or false. This will be a string. We don't know what's in it. This code doesn't care what's in it. All it cares about is if the Boolean is true, it sticks OK on the end. Otherwise, it doesn't. So we have a test case. We want to make sure that our code uses the interface correctly. And again, this string is whatever you want it to be. The code itself, the compiler, the computer does not care about that string. That's just for people to read. So we need to create an instance of the mock class, right? So obviously, we've declared a variable called mock. It's an instance of that class, this one here, this mock class over on the left. We now want to require that do stuff is called, right? The mock class, again, this is the variable here. We're going to require that the do stuff function gets called. So we use this trompe l'oeil macro to ensure that happens. And we also want it to return, the mock to return true when it gets called. Now, I've put this on the line below purely for convenience. You could put it all on one line. Again, a statement only ends in C++ when you stick a semicolon at the end. But these two lines, the require call and the dot return, they could all just be on one line, right? As you know, I could put dot do stuff on a separate line if I wanted to. It's just breaking it up. The compiler doesn't care. And now it gets a little bit more interesting. We want to require that do other stuff is also called. And we have this underscore in there. Now this is part of trompe-l'oeil. This is part of the framework, this underscore. It's not a C++ thing. But who remembers what that underscore means? Collect all arguments. So you're basically there. It means I don't care what the argument is. Nor you can use this as a matcher. So inside the brackets, I could put an expected value. But in this particular case, I don't actually want it to check what is passed. You can usually restrict, otherwise you can restrict what matches. But I don't want to restrict any number, whatever, just match this. But I do want to verify we are given the correct value. So with the first argument being 1, 2, 3. So obviously this is 1, 2, 3 up here. So I want the mock to verify that it is in fact called with 1, 2, 3. Is this code making sense? Is anyone not understanding it? If so, speak up now.
The prior call to require from,
So in the previous call?
yes.
Yeah.
So in our function, we have not defined the function, so we don't actually know under which circumstances it would return whether true or false.
No. So the mock, this mock class here, right, where we have do stuff, when you call mock.doStuff, that's going to return true because this is not a check. This is an instruction. This is a command. This is telling trompe-l'oeil return true when this gets called.
Okay.
And if it doesn't, and if somehow it doesn't get called, fail the test. Yeah.
If you wanted to check the first argument was 1, 2,
That's this line, yeah.
okay, but you can't.
Ah.
Score in
Aha.
other stuff.
So you could put 1, 2, 3 there, but you will actually confuse yourself if you do it that way. The reason that you would use 1, 2, 3 here is if you wanted separate cases. So I could have like require call, do other stuff 1, 2, 3, and have another require call, do other stuff 4, 5, 6. This is for matching, not for checking, right? It's when a function might be called multiple times, and you want a require call to say, oh, is this the one for this particular case? No, it's not. Try another one. So you can have multiple lines of require call, and you use this bit as a matcher so that it can dispatch the correct one that's then going to return whatever value you want.
But then you're just checking do other stuff. You're not checking function to test.
What do you mean?
Well, if you're saying require call do other stuff 1, 2, 3, are you testing func to test?
So let me explain it this way.
Are you testing do other stuff?
If I put 6 here, right, the test will fail, but the error you'll get will just say do other stuff was never called. But actually it was called, but not with the value that's supposed to match. However, by doing it this way, if this is the wrong value up here at the top, then it will instead say, well, do other stuff was called, but it gave us the wrong argument value. So it's more, it makes it more readable when it goes wrong, right? It's the intended use case. And we're telling trompe-l'oeil that we want our mock to return the string yes. So this, obviously, the ret variable will get yes in it. And then we just call it, right? Now, this is now catch, right? Catch has the require statement. So all of these preceding lines were trompe-l'oeil, the trompe-l'oeil mocking framework. The final line here that I've just brought up is catch, the catch test-driven development framework. So we now actually use the function, and we pass it this mock implementation of the interface. So this is just taking a reference to interface. It doesn't know anything about the implementation, this mock implementation, but we give it to it because obviously it just takes the base class, right? That's how inheritance works.
Test case catch as well.
Sorry?
Test case is catch.
Yeah, so test case is also catch. Yes, sorry. And obviously we expect that the string that's returned will be yes, okay, because that will be the okay variable will be true. Ret will be the word yes. Since it's true, it's going to add on a space and okay, and then return it, which means that this will pass.
Before you
Yes. No. The test case is just defining some series of stuff you're going to do. We create the instance of the mock on this line, right? Because we have the type, which is mock, and an instance of it, a variable called mock in lowercase. So the test case is just a logical grouping of some thing you're going to do, right? So I can create a test case with absolutely no code in it at all. And catch will just, obviously it's going to pass because there's nothing to check. So it's just a way for you to organize your tests, right, for your convenience.
My question is on the sequential order of those three.
So your question's on the sequential order of what, sorry?
Of require, right? So you have three. I cannot read it very well. It's on a color that I cannot. It's require, right? Or is it request?
Require call.
Require call.
Yeah.
And then require call, and then the final is require. Okay. So just bear with me. The whole thing is this: if you want to pass the require call, the first one, you'd better have done the require last one already, isn't it?
No. So before we can actually invoke the function and check that the function returns the correct value, because obviously require is just a test for something being true, right? We require that there's some Boolean true, so obviously we have equals equals that string. So that's either going to be true or false. But before we can actually call the function with the mock, we have to tell the mock what it's supposed to do. All of this require call and this require call are telling this mock class how it should behave and what it should expect. We have to tell the mock what it should expect and what it should do before we can give it to this. Otherwise, if we do this bottom line first, the require func to test mock equals yes, okay. If we do this first, we're giving it a mock that we haven't actually programmed with its expected behavior. So it's going to just, if this was the first line, it's just going to call func to test. It's going to give it the mock. It will call do stuff, and the mock has no idea what to do. It has no idea what to return because we didn't tell it. It will do other stuff, and again, it has no idea what to return because we didn't set it up. So this setup you have to do first before you then give it to your implementation to use. Otherwise, it doesn't know what to do.
So in a regular
Sorry, one second.
regular unit test, what you would do, or other framework, is that you would have two test cases. One is testing do stuff, unit test one, do stuff, return true if blah blah blah. Unit test two, call do other stuff, return true if blah blah blah.
You might, but that would only be applicable in the case that those two functions have no dependency. So the reason that obviously this test is actually reliant on both is because there is a clear dependency between them, right? The result that we get out of this function depends on both of these things. It depends on what this one returns, and it also depends on what this one returns, right? They are tied together. I can't have two test cases that just set them up independently because they are inherently tied together. That is simply a matter of whether there is a dependency between those mock functions or not. Yeah, sorry, you had a question. Oh, okay, cool. So, now let's talk about what not to do. And the first one I see quite a lot actually is don't test the mock class itself. Don't write, require, or check statements that verify your mock class. The mock class is there to feed data into your implementation or to expect data from your implementation. Don't write tests that end up actually verifying the behavior of your mock itself. I've seen this time and time again, which I think comes from people who don't quite understand how mocks work. But if you've got a test that's calling a function, if you're calling functions on your mock in your test code, you've made a mistake. Any mock functions should be called only by the implementation. Your test code should not be calling any functions that the mock has. It can, it can do the expect call and all that stuff, that's fine, but don't then call them. Yeah, everything should be in the code intended for production. And also this is just be fairly obvious, don't write mock classes by hand. You could. I could write a brand new mock class for everything I need to do and not use any framework, not use Trompe-l'oeil, do it all by hand. It would take me absolutely ages, it would be horrible. Don't do that either. So is there a question? And also avoid making them too strict in what they expect. So as you saw in the previous case, which is obviously contrived, we basically expected that it would return 1, 2, 3, right? Our mock was expecting exactly the number 1, 2, 3, which may make sense in a real life situation. Maybe given some input, your production code that you're going to test should pass a very specific value to a mock, and then you should verify it. But maybe in certain cases it doesn't make sense to make it that brittle, right? Maybe you want to test if it's a range of values, or potentially it's some internal implementation detail that you don't care about. Yes, question.
Let's say in the function that I'm trying to test, the function would call other methods on the mock, but which are not critical to determine the return value of the function.
Which are not critical.
Yes, which would not influence the return value.
Yes.
That means I can leave them out.
So you probably can't leave them out, but there's a separate macro that Trompe-l'oeil has, for example, for this exact scenario. You can have allow call. So if it's conditionally going to call it, and it's an implementation detail that's not something the test should care about or know about, but in the event it is called, you've probably got to give something back, right? So in the event it is called, you can have this allow call syntax. So instead of require, you put allow, and then that allows you to do all the same stuff, but the test won't fail if it's not called. So you're allowing it to be called, and in the event it does get called, you can tell the mock, well, you should return this value. That's how you solve it, right? In the event it happens, give it back this. If it doesn't happen, don't care, don't fail the test. And obviously, yes, just don't make your tests too brittle, right? Also, don't make your tests too sort of flexible either, right? If you write mocks and they're all just allow, and there's no actual verification going on at all, it's probably a bit too flexible. Someone can come along and change the behavior in a way that they probably shouldn't, but the test will still pass. So it's a bit of a balance, and it depends on your exact scenario. So this is somewhat sort of fuzzy guidance on my part, but again, unless you've got a concrete case, it's not something I can really give you a specific answer on.
How would you do exceptions? Would you follow the exception, or would you just
How do you?
as being called
Oh.
and then pass the test? And then pass the test?
Okay, so the question was how would I deal with exceptions? Are you talking about throwing an exception inside a mock?
Or your function throws an exception. Do you just, does the mock just come back and say an exception's been thrown, and that's the end, that's to fail the test?
Well,
or do you follow the exception until it's solved?
so that's very sort of no, not broad. It's just very difficult to come up with a scenario where that could happen, because don't forget, the implementation is calling your mock, right? So they can't, once they've called your mock, you're inside the mock. So the only thing that can throw an exception is the mock. The only way you could break that, well, the only way you could get around it is if the mock took an argument, which was a lambda, or something else to call, and then you passed a callback, basically a lambda, to your mock, and the mock then called the callback, and the callback threw the exception. But the answer to that is that that's fine. You can have a handler in your mock that expects the exception to be thrown, checks that it's the correct type of exception, and passes the test. So you can also expect exception. Catch happily lets you verify that exceptions are thrown.
I was thinking the other way. I need to think of it that way. Yes.
Okay.
So that was good.
Question from Michael.
I don't remember if we had this question already before, but if you want to define a case that should not compile, would you be able to do that?
Define a case it shouldn't compile. So the short answer is yes. but the longer answer is not generally through a testing framework. That's basically something you would do through your build system, right? So you'd want, you can't do that in code really, because obviously it's code that can't compile. But you can totally have, via say CMake, you can have a particular task that you expect to fail to compile, and if for some reason that thing does compile, that's the build system returns, you know, not 0 basically. So yes, you can do it, but it's not something you do in catch. It's a separate layer.
Believe it or not, it is possible to use Oracle template metaprogramming to test that you cannot call a function. Calling a function will give you an error. It's really complicated.
Spheno, basically. Yeah. Yeah, you could use Spheno to detect that. Substitution failure is not an error, for those wondering, which we'll probably get into in the next module, by the way. Yes, question?
Question on the practice of mocking.
Yes.
So if you go to page 4,
Okay, let me just go back a sec. Yep.
like you are a very experienced programmer, so is this what you would do? Let's say if you have to, let's say you have to implement something called interface, and that defines a bunch of
Yes.
functionality. Would you actually do a mock to start with? Like when you start constructing your class structure, you would say, okay, testers, I have a mock class ready. You go write tests according to this, or is that something you actually do it afterwards?
So the question was, would I start with a mock, or would I have an implementation? And the answer is actually yes and no. So yes, sometimes I will start developing my implementation class, function, whatever, usually a class. I tend to be object oriented. And I may not have written any implementation for, you know, a given interface. And so I'll build out the functions I'm doing, and then later I'll create a real implementation to plug into it. However, sometimes that's not true. Sometimes I'll define an interface and I'll go and TDD develop my, you know, implementation of interface and have a real concrete one. But the one thing I will still not do is go and work on a class that's going to use this, you know, interface. And one thing I will not do is give it the real one that I already worked on and already did, because they should be separated. Even if I've already written a real implementation of interface, when I come to write something that uses it, I will still use a mock. I don't want to plug an implementation into something using an interface, into something using, you know, I don't want to tie those two classes together because they don't know about each other. They shouldn't be coupled to each other in the tests. Ideally, yes, they shouldn't be, right? I want to keep everything separate. I can plumb it into each other later, right? And I can write an additional layer of testing, which is integration tests, right? My unit tests keep everything separate, right? None of the classes know about each other. They're all they're interfaced away. They're all independent. They do one thing and they do it well, and the unit tests verify they're correct. When I do plug them into each other and I have the final executable, I have a second layer of tests. I run the executable, and then I start, you know, punting data into it externally via whatever way that is, standard input output over the network, whatever it happens to be. And I verify that it returns the correct stuff. It does the correct behavior when I've plumbed everything in. But that's the next layer of testing, right? We've gone from, you know, the C++ baked in unit testing to the next layer in the pyramid. Those tests could arguably be written in Java, Bash script, Ruby, right? If it's over the network, why bother doing that? And why bother writing that test code in C++? Just something quick and simple that's just going to give it data and get data back and check it. So it's another layer of the testing pyramid. You absolutely should do it, but when it comes to the bottom layer, which is the unit testing, no, keep them separate. So where were we? Using a framework, maybe too strict. Yes. Right. So now we're going to go back to the code. Back to the code. If you've missed out on previous content, don't you worry about it. We have a branch for you to start working from. So you can go to this URL. I know it says lesson 2. Don't worry about that. Just grab it, clone it, And the Git branch you want to check out is called lesson 5. So last time we did this, it was the same repo of lesson 4, and this new one's going to be lesson 5. I think we'll take a few minutes to let everyone get set up, and also so I can rest myself. And I'll also get my laptop set up for the live coding as well. So let me try and transition this as seamlessly as possible. Right. Where is the display? I think I'm blind. Tristan, am I going mad, or is there not meant to be an icon in the top bar for changing the display from independent to mirrored? Because I'm either blind or it's missing.
It doesn't appear for some reason, but if you go to your
Display settings. Oh, that's a pain. That's a pain. Okay.
that's really weird.
That's the one I want. Right, here we go. Hopefully this will work. Okay. So I hope everyone's got. Did anyone need the URL? Has everyone got the URL? Okay. Tristan can paste it on. It's the same one you pasted last lesson, basically. TDD lesson 2. Just search for lesson 2 in our Slack and you'll find it. All right. So what time is it actually? Where's the phone? Oh, I thought you said a year for a second. Yes, it is. Okay.
Okay, I've pasted the URL for the GitHub repository into the Slack channel.
Cool. All right. 5 minutes, folks. Try and get it to compile, and if you can't, we will happily help you out.
You want the,
Uh,
sorry, I didn't, you want the lesson 5 branch, yeah?
I should mention, it won't compile at the moment. You'll need to comment out this line 82. If you comment out line 82, it should compile.
Ollie, you want the lesson 5 branch, yeah?
Lesson 5 branch, yes.
Okay, sorry.
It does compile. Yeah, you know what? It will compile. It's just C line, unfortunately, being silly. Let me just make sure. Where's tool appearance, build? Here we go. No, mine doesn't. It's not being silly. It doesn't compile. If you check out lesson 5, if you comment it out and we try and build it, it does indeed build. Okay, 5-minute break. 5 minutes. Right. doesn't touch the laptop. It just everything's saved to the USB stick.
And how much memory does the USB stick have?
I think the ones we had are 16 gigabytes.
And you have the whole operating system there.
Mhm.
Which is, I mean, you're just using it to run the code. You're not like.
Yeah, it's a whole live environment. Doesn't touch the laptop's hard drive. I can bring one next week.
I mean, I can probably bring a laptop I can use, you know, it would be easier.
Right. So, if everyone's ready to get started. So has everyone cloned it and they've got it working, I hope? Yeah? Okay. So I'll briefly recap where we got to from previous sessions. So the code you should all have if you've checked out the correct branch is we have obviously interfaces for a customer, as you can see. We have an interface, also put I at the beginning to represent interfaces, which represents something that you can rent out. We have an implementation of something that's rentable, which is a video, right? I can rent a video. So we have obviously a constructor for the video class, and it overrides, you know, the title of it, its type, it's a video, when the rental starts, when it ends, and obviously functions to set the start and end time if you rent it out, and then obviously has private data to store that information. And as you can see, obviously these are const accessible. Would anyone like to remind everyone what the difference is between these 4 const functions and these 2 non-const functions?
I'd love to tell you, but I'm a complete beginner, so I'll let you someone else.
Go ahead, at the back. Exactly, so these 4 are all getters, and specifically you can use them from a const instance of the class. These 2 are setters, these 2 down here. So obviously they can't be const because they're changing data. And so we have in our implementation, we have the customer code, which, you know, returns the name. And of course, you know, the constructor will set the names. And obviously because we can give them a rentable item, which they'll own via a unique pointer. We can take a rental off them via the index, so they can have more than one. And we can adjust the balance so the customer has how much money they've put on their credit balance, essentially. We have a video. And of course, in order to track the money, we created this money object, a money class rather, which has pounds and pence. And we essentially got into a whole load of work to make this thing work. So where we were at last time was really finishing off this class. And where was I? I lost where I was now. Is it this one? No. Oh, it was a rental controller, right. So where we got to is we were writing, and this was of course BDD style, so we had, the scenario is a rental return should be correctly handled and we should bill them, right? So someone gives their video back, we should then charge them for however long they had it per day. So we have an instance of our rental controller. So also given that, you know, some mock customer with a mock rental for 1 day, and 1 day costing £2.45, so they borrowed it for a day. When, you know, we execute the return, which is here, then the amount owed from return rental should be equal to £2.45. Obviously right now it doesn't compile, and the reason it doesn't compile is if we look at return rental, here it's a rental return info object, right? So this info has an amount owed, and it has the object that they rented out, which we can put back in the library of rentable items. So if we go back to our test, oh yeah, I should point out this is all in the same file at the moment. We have, for those who weren't here for the previous module, when writing tests, this is a matter of style, a matter of choice. I like to keep the actual implementation code in the same file as my tests initially, and then once it's got enough functionality, I'll take this and I'll move it out, I'll move it away. for now, since we're just working on it still, all the code is in one file for simplicity. So obviously, the amount owed doesn't match because this object is actually a class. So how can we fix this?
When you take it out, do you sort of mirror the whole file structure in the test file structure, or do you just put a test component sort of like?
So, oh, I see what you're saying. It should absolutely mirror the code. So in this case, it's a flat directory structure. We don't really have enough classes to justify having subdirectories yet. As your project grows, you arguably will want to start moving them into directories. And if I move customer into some subdirectory, I should then move test customer into a matching name subdirectory in the test section. You don't have to, but it's good practice. So obviously, since this is a class, how can we fix this? Anyone? Michael? Remember, precisely. So what we really want to compare is that. In fact, the naming's bad. I don't like this name. So we'll call it return info instead. And we'll call it return info here. And then in theory, well, I say in theory, we actually implemented it. No, we haven't. So this test should fail. Again, the key point to test is they're supposed to fail first. You only make them pass afterwards. And so what do we got? So, oh, that's wrong. So this failed. Right? We expected cost per day to be called, and it never was, because the implementation is effectively a dummy, right? We call remove rental, we calculate the amount of time it's been borrowed for, but we don't actually do anything with the information. So this code knows how much time we've borrowed it for. In order to return how long they've borrowed it for, what information do we need to compute? Oh, we know how long it's borrowed for. We've already done that, right? We got now and the rental start time. We know how long they borrowed it for. So what we really need to do, right, is have a variable that's going to store the cost to the customer, right? So cost, and we need to then grab the cost per day, right? So we have the rental, and the rental should know its cost per day. And we basically want to do the cost per day times the amount of time borrowed. But is that going to work? No, it's not. Because I can't multiply a money class by an amount of time. So
Convert the time to simple integer, static cast integer.
So yeah, you're right. Well, almost right. We want to so we're going to say that we always round to the nearest 20 by a number of hours, right? So 24 hours. Sorry, we need a variable for that. So days. So to use the H, you have to use chronoliterals. It converts it to a. Or does it? No, it's still not working. Let's just run this for a sec. That's better. Time borrowed. No, that's okay. That is correct now. Right. So sorry. Oh, sorry. So in order to use 24 hours, to use the H at the end, the standard library has this namespace chronoliterals, which then defines the special ability to represent time like that. So can we get the count? So we can say auto amount owed equals the cost per day times is that not right? I'm not getting very useful errors from C-line right now. But obviously it's trying to, yeah, here we go. So this is a number, right? So the days borrowed is going to be, it depends on the unit actually. But essentially we need to be able to multiply money by, why is it complaining? Sorry? Oh. We need an operator overload basically, right?
Yes, well, it seems to be complaining that days borrowed is a knock-off. It's clearly not.
Dot count?
Look where it's
Oh, sorry, you're right, sorry.
there and it's
Yes. No, is that? Yeah, you're right. Okay, good. So we need an operator overload for the money object, right? So we can implement an operator star. And we can say, you know what, we can template. We won't do templates yet. Well, do we really want to multiply it? No, it probably doesn't make sense, does it? Well, if you've got a money object that's, say, £2.45, you need to multiply.
I would say an amount times an integer that gives you another amount is about it.
You know, let's do the naive implementation, which is not optimal, but it will work. So we can say that for, you know what, we'll just do this, while days borrowed is greater than 0, and we need a money object first, so we'll have money amount owed plus equals naive, not optimal, but does it make sense? Put what in the lambda? Do we want to post increment or post decrement?
That would be the normal way of doing it.
It won't end up in one. Well, we'll see. So then we can return amount owed as the rental return info. We're missing part of the test though. We need to also check so we have the pointer and where is it? Did we keep the object? We moved it, right? So we keep the raw pointers and then we can just compare them here. So we need to make sure the object it gives back is correct. Oh, what's wrong with that? There we go. Okay. Which line? Line 90. We compare. We make sure it gives us back the original rental, and we make sure that the amount that's owed is £2.45. Yeah. So in this code, it's going to return amount owed. I haven't obviously given back the rental, so it should fail, but it should fail in a different way. So let's see what we get first of all. So we'll build it. So we require, oh, did we return rental end? No, we don't need that yet. So the cost per day, 245. However, we might have messed up the test. So the end is going to be start plus 25 hours, which is just over a day. But actually, if we look at the code, right, when we construct it, we have an end time for issuing the rental. And we say it's 245. Oh, it should be okay. So we have now management. You know what, let's just debug it. So we can go drop down to here. No, it's complaining that cost per day is never called, so it's more likely that this is never invoked. Days borrowed is probably 0. So if we now run it in the debugger, and sure enough, days borrowed is 0. So let's see what time borrowed says. So that's 68. We have the rental object with its pointer. Well, it's not very friendly to access, is it? No, that's not very good. So we access rental start, and start is now, and end is plus 25. So, actually, you know what we've done wrong? So the job of this is actually not to check the time right now. It's meant to check the rental end. So we can do rental end minus the start. And then we know. Of course, now the mock needs to tell it when it ends. So we now have the cost per day, have a mock customer. Let's kill that. And off we go again. Cool. So this has now passed, right? So so now the mock will tell it when it started, when it ended. So the start is set to now, and the end is just set to 25 hours in the future because it's all fake data anyway. The implementation gets the time borrowed by subtracting the start time from the end time, right? That's the difference. Does that make sense? We then divide the amount of time borrowed by 24 hours, and then however many days there are. Again, this is not optimal code. We can refactor later. We just increment each time by whatever the cost per day is. Where we're failing, though, is this. The rental object is null. So the money is good. The return info that we get from return rental is good. But the rental's not. So if we go to the implementation, what's wrong with the code? What do I need to do? Who knows what I need to fix? So the money's good. We've got the amount owed. If we return the amount owed, we need to return the rental itself. So how do I do that? I'll give you a hint if you want. I'll give you a hint if you want. So I have the rental is here, right? That's the rental object. That's the thing I need to return. I am giving back the amount owed in this struct, but I'm not giving back the rental. So what do I need to do with this thing? Don't overthink it. Super simple.
Return rental.
So well, the answer is I need to return it, right? The basic, I mean, you're not wrong, but the basic answer I'm looking for is you need to return the thing, right? This doesn't get returned. We just throw it away. Does that make sense to everyone? When I give this back, I return an object in this line. I'm not giving anything other than the amount owed. Sorry?
You just return money.
I'm only returning the money at the moment,
Yeah.
which is why it fails.
Yeah.
So we need to give that back. Since it's a unique pointer, yes, I do need to move it. But that's, oh, come on, don't freeze on me. I need to actually give the object back. So now I do. So if you run it again. Sorry? So this test, no, we do both. So this is return info. We check that the amount owed is £2.45, but we also check that the rental item is the one we originally gave it. So we have, this is the one we're going to get, this is the one we give it, this mock rentable. We obtain a pointer to it so we can compare it later. And then on this line, this is the line that's failing, right? You can see here at the bottom, this failed, right? It was supposed to match and it didn't, because we weren't returning it. So now, with this code, actually giving it back here should work. So if we try it, it passed. So we now have a working system. We have a rental start, a rental end, and we have the cost per day.
Where are you storing your rental return? How do you still know whether it's in or out?
Sorry?
How do you know whether the video is in the store or out of the store? Is return pointed to the rental?
No. So when return rental is called, right? It's going to take it off. It takes it off of the customer. It calculates the appropriate bill, and whoever's using our rental controller is then given back the rental to deal with.
Okay.
So the rental controller is not going to put it anywhere. It's going to give it back to whoever's using the function. So essentially what we want to do, right, is have a shop manager class. So that will call the rental controller and say, right, this is done. He's done with it. The rental controller will give the appropriate billing information. It won't bill them. The shop manager will take care of billing, but it will tell the shop manager, right, you need to bill him this much. Here's the video. And then we can put that, we can have a video library class that we can then put the object back into.
My thing would just be to change the library list of videos
Yes.
in or out.
And
Just return and just
and that's a perfectly
change that
yeah.
vector of
That's a perfectly viable way of doing it, arguably, and probably and actually it's most likely reasonably efficient. The one benefit you get with doing it this way, though, is that because it's actually a physical object, you can't forget to mark it as rented or not rented, because there is no is it rented or not. It either lives in the library class or it doesn't live in the library class. Once it gets rented out, it would be taken out of the library class physically and put on the customer. So now the customer has the object.
I can see that now, because if I start changing, I'm in the local variable. I'm crossing rather than just turning blank with the video. I'm actually changing a reference to an array that's being used by a video.
You're manually tracking it, right? The difference is that if you have some booleans that say like yes, rented, not rented, that's manual tracking you've got to think about. In this particular case, because we physically pass around the object, right? Either one class has it and another one doesn't, or it does. There's no way to actually we don't do any manual tracking anymore. It's either going to live on one class or it's not. Yeah. Question, yeah.
So, in line 20.
This file.
Yes. So
That's a closing brace. 28, yeah.
So this curly brackets means that you construct the this object.
We construct an instance of the return object. So C++ figures out for us what it is because it knows here on line 21 that it's that. You could alternatively write it like that. It will do exactly the same thing. Maybe it's a bit more readable if you're not familiar with the curly brace syntax.
The other thing is if you have an explicit constructor, then you have to use.
Yes, if
You have to say this. You can't
if the constructor for rental return info was explicit, if you don't know what that means, don't worry, then you wouldn't be able to do this. In this particular case, we don't, because it's not explicit, we're allowed to just shorten it like that. Does the same thing, though. Make sense? Okay.
Excuse Dental. Yeah, that's the C++ standard.
It's the namespace for the C++ standard library, yeah. So the reason we have to move, who remembers why I have to use move? Why can't I just...
Because it's
My opinion, a couple of questions about this. So here you're using structure. There are no constructor, but if you are want to return a class, which class?
This is, well, return rental info is still could be a class, right? I can change that to class, and then to make it carry on working, all I have to do is put public, and then that's exactly the same. It's exactly the same as just struct. The words class and struct are completely interchangeable. The only difference between class and struct is the defaults. If you use class, it's default to private. If you use struct, it's default to public.
If you have several constructors depending on parameters, so you put the needed amount of parameters in this curly brackets, and then compiler will choose the needed constructor in class. Am I right?
You
When you have a constructor with two parameters and a constructor with one parameter.
So you're saying if I have return rental, rental return info. You like this, you mean? Return rental info, money, and then the other argument. You mean this constructor like this? Yeah? So, so I'll just finish this off just to make sure I'm matching what you expect. And R will construct from, not R, sorry, rental. So you mean a constructor like that, essentially, yeah? This constructor?
Yeah, and for example, another one which takes only one pointer and set amount port to 0.
Yeah, you can define that if you want. There's a caveat, though.
So when you're returning one parameter, then compiler will choose the second constructor. Am I right?
As long as it's not compatible with, so there's unfortunately, in C++ 20, which is not out yet, this issue will be fixed, but in C++ 17 and earlier, because these are public, money and the rental object, if you use curly braces, which I was using in the return statement, it will bypass my constructor. Because the two data fields are public, the curly braces will bypass any constructor I define, and it will be aggregate initialization.
No. Not if you have used defined constructor like this. It's fine. The issue was if your own constructor was a default constructor was equals default or equals delete.
Oh, an explicitly defaulted.
This is very definitely not an aggregate, so you want to know.
An explicitly defaulted constructor. Yes, he's right. Sorry, so it won't bypass it.
So this will always call it.
That's true. Sorry, yes, he's right. It was with an explicitly deleted default constructor. So never mind. If you define that, it will call it. Yeah.
Is it a case of destructure? Or could you even get the information from the class out of the class again by destructure and do these calculations?
Can I get the information out of the class by what?
Let's say that you
Oh, you're talking about structured bindings.
yes.
So you're asking, yeah. So what we're doing here actually is we could do auto.
First of all, is this a case of destructure?
You would be able to use structured binding.
But
It's the two members of public. Oh, no, can you? I'm not sure, actually.
It's an aggregate, so it should be.
It's not an aggregate because it gives you a constructor.
No, I deleted that. It's gone. So we can do it this way actually if you want. That's the C++ 17 feature. Does the same exact thing. These are essentially just referring into the data in the struct. They're not copies. I can take this. If I do that, it's a copy of them, but there's no reason to copy them. That's the exact same code.
I would have to match all the numbers that are in this construct. I wouldn't be able just to.
Oh, you can't partially extract them. No. But you could just pick some random names for the stuff you don't care about. It's just syntactic sugar. It doesn't result, the machine code's the same.
Really handy, for example, if you're grabbing something from a map, or if you dereference a map iterator, it gives you the key and the value, and it's really handy for that, because you can just rather than and tuples as well.
Yeah, it looks nice, basically. Tuples, pairs, it looks nice. Okay, so we've written a rental controller now that has the ability to issue a rental. That was from the previous lesson. We obviously were working on return rental. And it has the ability to, well, return a rental, right? So is there really anything else that we think the rental controller should do for us? Yes, Jonathan. Ah, yes. Go on. What was the question about the move? Sorry, I got sidetracked.
I think is you can't with a single ampersand. You can't copy. You have to.
So are you talking about the structured binding here?
No, without all that syntactic sugar.
You originally asked what's the need for standard.
Oh, sorry, that was up here. Why did I need move here? Because unique pointer is only movable. You can't copy a unique pointer.
And you have a double ampersand.
No, that's not a copy.
Doesn't that allow you to copy?
No. It's an so that's an R value reference. It's a different kind of reference. We're running out. I've got a few minutes. No, it's basically a different kind of reference. Are we getting close to 9? What's the time? 2 minutes too. Okay, well in that case, all right, we've got a fair bit of test code here. I'll spend the last 2 minutes just taking you through, for those who missed it, what we went through last time, or a refresher for the rest of you. We tested our customer. This is all TDD again, and it's really simple stuff, right? When I say really simple stuff, I mean that the actual tests themselves look really silly and simple, right? If I construct a customer class with John Smith as the name, oh, this amazing feature that's been added to C-Line. You're looking at it right now. Do you see how you have a little highlight? It's not part of the code. You see where it says name and it says address? Those are not part of the source code. They're a little feature of C-Line now where it actually tells you what the constructor parameter variables are called. So if I show you the class itself, you will see that the constructor has that parameter called name and that parameter called address. So as just a little feature of the IDE of C-Line, it now shows you what you're actually passing into what constructor variable or function variable or whatever. Super handy. Nope, just get the new C-Line. It just passes your code and it works. Not only does it give you the names, it will even show you when a variable you pass is being taken by reference or by value.
But if you define your class in a header file and then implement it in a source file, and you include the header file and you didn't use variable names, you would not.
Oh, it can't. Yeah, it can't figure it out then. Although that actually raises an interesting question. I think if it can see the source code, if it can see the implementation, it might still figure it out.
The problem is with all the standard library functions that you don't see variable names.
Depends on the implementation of the standard library. Certainly on Clang, most of them have names. But that's implementation specific. Don't worry about that. If you use the standard library, sorry, nothing you can do. That's Java though. Java's had it for ages. Yeah. This has been this feature we've got for C++. They've had it for ages in IntelliJ for Java. They've just added it for C++. It's wonderful. You're right. So many less bugs. Like you can see here as well. The variable name is obj. Obviously that's part of Trompe-l'oeil, but you get the idea. Anyway, it is 9 o'clock, so I am very briefly going to switch back to the slides. And as ever, oh, no, where have you gone? I've lost my mouse. Yes. Thank you very much, everyone.
Some stickers I forgot to say at the beginning, and I'll